Hello friends, in this video we are going to solve a problem on how to sketch the root locus of a control system whose open loop transfer function is given to us. So let's take a problem. So our problem is to sketch the root locus of the system, and the open loop transfer function is given to us as k s plus 2 upon s to the power 4 plus 3s cube plus 4s square plus 2s, and here the value of k, it is greater than or equals to 0, and the system is having unity gain feedback, okay, that is hs equals to 1. So let's solve this problem. We are given this open loop transfer function, that is gs equals to k s plus 2 upon s to the power 4 3s cube plus 4s squared plus 2s. Let's simplify this transfer function. We can take here s as common, so it will be s cube plus 3s square plus 4s plus 2. Now simplify this equation. We have gs equals to k s plus 2 upon s. We can take s plus 1 as common, and the remaining term will be s square plus 2s plus 2. We are doing this because our first step to sketch the root locus is to find out the poles and zeros of the system. So for poles, we have to use the denominator polynomial and equate it to 0 and then find out its factors. So we are just simplifying the denominator polynomial so that it will be easy for us to find out the poles and zeros of the system. So this we have simplified it completely. Now let's find out the poles and zeros. So our step 1 will be to determine the poles and zeros. For poles, our denominator polynomial is s plus 1, then s square plus 2s plus 2. So equate it to 0 and find out the poles. We have s equals to 0, s equals to minus 1, and s equals to minus 1 minus j, minus 1 plus j. S equals to 0 is obtained from here, s equals to minus 1 is obtained by equating this to 0, and these two complex poles, they are obtained by equating this quadratic equation, that is s square plus 2s plus 2 equals to 0. So we have obtained these 4 poles. Now for zeros, we have to obtain the numerator polynomial to 0, so that is s plus 2 equals to 0. So we are having s equals to minus 2 as our 1, 0. Okay. Now we know that the root locus, it starts from the poles and terminate at zeros. So our one pole is s equals to 0. It will start the root locus branch. It will start from s equals to 0 and terminate at s equals to minus 2. So the number of branches, we know that number of branches of root locus, it is equals to number of poles. So branches will be 4 because we are having 4 poles here. So for these 4 poles, s equals to 0, it will start from this pole and it will terminate at the 0 s equals to -2. And the remaining 3 poles, they will start from s equals to -1, s equals to -1 minus j, s equals to -1 plus j. So these 3 remaining branches which we have, it will start from the pole and it will terminate at k equals to infinity. Okay, so this we have find out that what is the starting and the ending points. These are the starting point of the branches and these are the ending points of the 4 branches. Okay, now our second step will be to find out the angle of the asymptotes. And we will find out the angle of the asymptotes of the root locus for different values of m. How we can find out it? We have the formula for the angle of asymptotes as theta equals to 2m plus 1 into 180 degrees upon p minus z. And m is from 0, 1 till it is p minus z minus 1. P is what? Number of poles. 0 is what? Number of zeros. So number of poles we have 4, number of 0 we have 1, then minus 1. So it will be 2. So m will be 0, 1 and 2. Okay, up till 2 we have this value of m. Substitute the values and find out the values of theta. So for m equals to 0, we have theta equals to 2 into 0 plus 1 into 180 degrees upon number of poles we have 4, number of zeros we have 1. So it will be 180 degrees upon 3. So theta will be equals to 60 degrees. Then we have m equals to 1. So theta will be 2 into 1 plus 1 into 180 degrees upon 4 minus 1. So 2 into 1 plus 1, that is 3, and this is 4 minus 1, 3. So our angle will be 180 degrees. Now for m equals to 2, we have theta in 2 into 2 plus 1 into 180 degrees upon 4 minus 1, that is 3. So 2 into 2, 4 plus 1, 5. So 5 by 3 into 180. So we are having the value as 300 degrees. So for different values of m, we have obtained the angle of the asymptotes as theta equals to 60 degree, theta equals to 180 degree, and then theta equals to 300 degrees. Okay, these are the angles of the 3 asymptotes. Because number of asymptotes, how many number of asymptotes we are having? So number of asymptotes, it is equal to number of poles minus number of zeros. Poles we are having as 4 and zeros we are having 1. So we are having 3 asymptotes. So for these 3 asymptotes we are having 3 angles. Now the second part of this step is to find out the intersection point of the asymptotes with the real axis. How we can find out this? We have a formula x equals to summation of p minus summation of z upon p minus z. So summation of p means that we have to sum up all the poles, and then summation of z means we have to sum up all the zeros. So putting the values of the poles, we are having poles at s equals to 0, minus 1, minus 1 minus j, and minus 1 plus j. Then we have 0, 0 is s equals to minus 2, so putting its value here. Number of poles is p, that is 4, and number of zeros we have 1. So x will be minus j plus j, they will be cancelled out. So minus 1 minus 1 minus 1, that is minus 3, plus minus minus we are having plus upon 4 minus 3 is 3. So x is equals to minus 1 by 3. This is the intersection point of the asymptotes with the real x's. Now next step, that is step number, we are having step number 3. So our step number 3 will be to determine the breakaway point. How we can know that we have to find the breakaway point or not? Just first plot the poles and zeros to determine the direction of the branches of the root locus. We are having this as imaginary axis, this is real axis. Our first pole is s equals to 0, so s equals to 0, we are having one pole. Then we are having one pole as s equals to minus 1. Then complex poles we are having as s equals to minus 1 plus j and minus 1 minus j. So this is s equals to minus 1 plus j. This is s equals to minus 1 minus j. This is s equals to minus 1, s equals to 0. We have one 0 also at s equals to minus 2. So this is s equals to minus 2. Whenever we have to denote the poles and zeros on the S plane, then we denote the poles by the cross sign and zeros by the circle. So this is a 0, this is a pole. We are having 4 poles and 1 0. Now for direction, we take a point here. And to the right hand side of this point, count the number of poles and zeros. We have 1, 2, 3, 4, 5. We have 5 poles and zeros on the right hand side of this point. So for this 0, the direction of the root locus will be towards this point. Okay, that is in this direction. Okay, now for this point here, if we take a point here, then the number of poles and zeros on the right hand side will be 1, 2, 3, 4. So the direction of root locus will not be towards this point. Now for this pole, the number of poles and zeros on the right hand side, if we take a point here, then 1, 2, 3, 4, it is an even number. So the direction of root locus will not be towards this point. Take a point here, the number of poles and zeros is 1 on the right hand side. So the direction of root locus will be towards this point. So we have find out the directions. Now here we are having, for this pole if we check, then take a point here. Number of poles and zeros is odd, that is 1. So the direction of root locus will be towards this point, that is here. So for this pole and this pole, we are having the direction of root locus towards each other. So the branches from these two poles, they are going to coincide at a point. So for this, we have to find out the breakaway point. What is breakaway point? The coincident point where the root locus branches from two adjacent poles, they are coinciding. Okay. So step number 3 will be to find out the breakaway point. Now for determining the breakaway point, we have to differentiate the open loop transfer function Gs with respect to S and then equate it to 0. Okay, so Gs it is given to us that GS is what? K upon S plus 2 upon S plus 1 S square plus 2S plus 2. So differentiate this equation with respect to S and then equate it to 0. So we are having from the equation of the open loop transfer function, we can write the characteristic equation will be 1 plus GS HS equals to 0, and HS is given to us that it is a unity feedback system, so HS will be equals to 1, so 1 plus GS equals to 0. Putting the value of GS here, K S plus 2 upon S to the power 4, we can multiply this inside, so we are having S to the power 4, 3S cube plus 4S square plus 2S equals to 0. Solve this, we will get K equals to minus S to the power 4 plus 3S cube plus we are having the value of K as this. Now instead of differentiating this GS with respect to S, we can also differentiate this K. So dk by ds, it is minus, we are having this S plus 2, so this is S plus 2, differentiation of this term S4 plus 3S square will be 3S cube will be 4S to the power cube plus 339S square plus 428S plus 2 minus, we have the differentiation of S plus 2 will be 1. Okay, so the remaining term will be as it is and it will be multiplied with 1. So we will write S to the power 4 plus 3S cube, and in denominator we will have S plus 2 whole square. This is the differentiation of K with respect to S. Now equate it to 0. So we will have here S to the, when we solve this we will get S4 plus and we have to equate it to 0. Now when we simplify this we will get our last equation as okay. So if we solve this we have to find out the breakaway point by finding the factors of this. So the breakaway point we will get the values as S equals to minus 0.48 and S equals to minus 2.503. Okay, so these are the two values, because we are having here S to the power 4, so we will have two values of S equals to minus 0.48 and S equals to minus 2.503. So these are the two breakaway points. Now next step will be to find out the angle of departure. Angle of departure, it is obtained for the complex poles and it is given by phi d equals to 180 degree minus phi p minus phi z. Phi p, it is the sum of all the angles subtended by all the remaining poles, and phi z is the sum of all the angles subtended by the zeros. So let's find out the phi p and phi z. So phi p, it is equals to, we have four poles here. So for first pole, we will be having phi p1 plus phi p2 plus phi p3. Now let's again take these location of these poles. We were having s equals to -1, s equals to 0, -1 plus j, -1 minus j, and then we have a 0. So the angle can be found out by for this pole, if we find out the location of this complex pole, that is -1 plus j. So first we will find out for this pole the angle of departure. So our phi p1 will be this, phi p2 and phi p3, and this is phi z. Okay, because we are having only 1 0 here. So phi p1, it will be 135 degrees. This. How we are getting it? We are having this angle as 90 degree. This is as 90 degree. Okay. So this angle will come out to be 90 plus 45. So this will be complete angle will become 135 degrees. For this phi p2, the angle subtended will be 90 degree, because this is s equals to -1. So just above it, so angle will be 90 degree. Here also we will be having 90 degree because this is s equals to -1 minus j. Okay, and phi z, it is 45 degrees because this angle is 45. This is 45 degrees. So this angle will also be 45 degrees because this is again 90, and some of these angles in the triangle, it is 180 degrees, so it is 45 degrees. So we have obtained all the angles, substitute their value in this formula and obtain phi d. So phi d will be 180 degree minus 135 plus 90 plus 90, and phi z is 45 degrees. So phi d will be 180 minus 270, and it is minus 90 degrees. So the angle of departure from the complex pole will be minus 90 degree. Now next step will be to find out the intersection of the root locus with the imaginary axis. For this, we will use the root stability criteria. And for root stability criteria, we will form the roots array. So root array, we have to first obtain the characteristic equation. So characteristic equation for this system is, we have already obtained it. What you have to do for characteristic equation, you have to put 1 plus gs hs equals to 0. Hs here is 1, so you have to put 1 plus gs equals to 0. Gs value is given to you, so just solve this and obtain this characteristic equation. Okay. Now using this characteristic equation, form the roots array. Highest power of s is 4. So here we will have s to the power 4, s cube, s square, s to the power 1, and s to the power 0. Coefficient of s to the power 4 is 1, s square is 4, and s to the power 0, it is 2k. Coefficient of s cube, it is 3. S to the power 1 is k plus 2, and then 0. For this, multiply 4 threes and then 1 into k plus 2 and divide with 3. So it will be 10 plus k upon 3. For this coefficient, multiply 3 with 2k, 1 with 0 and divide by 3. So it will be 2k. This is 0. For s to the power 1, multiply this with this, 3 with this and divide by this term. So you will get 20 minus 10k minus k square upon 3. This is 0, this is 0. For this coefficient, multiply this with this, 10 with 0 and divide by this. So it is again 2k, 0, 0. So we have completed this roots array. Okay. Now for the stability, we have to put these coefficients, these values should be greater than 0. So k should be greater than 0 for stability, and this 20 minus 10k minus k square by 3, it should also be greater than 0. Okay, because root stability criteria says that the first column terms, they should be greater than 0 and they should be non-negative. There should be no sign change here. So for this has to be greater than 0. So for the value of k, to determine the value of k, we have 20 minus 10k minus k square greater than 0. Greater than 0, or we can equate this to 0 to obtain the value of k. So k is equals to minus 10, because it is a quadratic equation. You can have your value This is a quadratic equation. You can find out its roots by using the formula minus b plus minus under root of b square minus 4ac upon 2. Okay, so we are having here minus 10 plus minus under root of b square, that is 10 square 100, plus minus 4ac, and a is what, 1, c is 20, so it is 80 upon 2. So k will be minus 10 plus minus under root of 180 divided by 2. So k is equals to 1.705. You have to only substitute the value of b, a and c. A is what here? Coefficient of k, that is a equals to 1, b is equals to 10 and c is equals to 20, minus 20. Okay, so just put the values here, you will get the coefficient, the value of this gain k. Now form the auxiliary equation. Auxiliary equation, how can one obtain it? You have put this coefficient to 0. So just above it, use these coefficient. We have 10 plus k upon 3 s square plus 2k equals to 0. This is our auxiliary equation, or the subsidiary equation. Now here put the value of k and obtain the value of s. So it is 10 plus k is what, 1.705 upon 3 s square plus 2 into 1.705 equals to 0. So we will get 8.295 s square plus 10.23 equals to 0. So from this equation, we will get the value of s as 1.11 j plus minus. So for this problem, we have obtained all the values. We have obtained breakaway points, poles, zeros, angle of departure and the intersection points. So our last step will be to just sketch the root locus. So we will next sketch the root locus of this control system. This is our imaginary axis. This is real axis. Okay, and we are having the poles as s equals to 0, s equals to -1. We are having a 0 at s equals to -2, and we are having two complex poles at s equals to -1 plus j and s equals to -1 minus j. This is s equals to -2. Now for this pole, the direction of the root locus will be starting from this pole and terminating towards k equals to infinity. And for this 0, we have obtained the directions earlier also. Let's see what were the directions of the for this 0, we were having the direction of root locus towards infinity. So here we have one branch terminating towards k equals to infinity. Okay. Then for this pole s equals to -1, we have the direction of the root locus branch towards this. So it will go to this side. For this pole, direction of root locus was towards, and we were having a breakaway point here as s equals to -0.48, and another breakaway point was here s equals to -2.503. This breakaway point is due to this pole and this pole. These poles, we are having a root locus branch The root locus branches due to these two poles. They will starting from the poles and they are going towards infinity. So they are meeting at this point, and this is our another breakaway point. So these two are the breakaway points. Okay. Now they are breaking here, so they will go towards infinity. They are going towards k equals to infinity. Now our next step will be to draw the asymptotes. For this we have the asymptote. These are the angles which we have obtained of the asymptotes. 45 degree, this was 135 degrees, and this was 90 degree, 90 degrees. This was 90, 90 and 135 and 45 degrees. So we have 1, 2, 3 and this is our fourth asymptotes. They are meeting here. So in this root locus sketch, we have marked all the points, the breakaway points, the asymptotes and the direction of the root locus. So I hope this problem is clear to you. Thank you.